I would like to ask him this question if I had a chance. And I would say, I have a cup of water and I have my vacuum chamber and I take it down toward 10 to the -1 and it starts to outgas. Then we do the same experiment in the space station, which they've done before. And they put it in that little airlock container and the water outgasses. So if it outgasses down here and it outgasses out there, and if blood boils in a vacuum down here without a spacesuit on, and it does the same thing out there in space, then why do you need walls that are half an inch thick down here for a vacuum chamber to do the same thing that you're doing up there with no chamber at all? Does this make any sense to you?
Good question, though.
So that would mean that the spacesuits would have to be half an inch thick of some type of metal, like a vacuum chamber has. I mean, that's just common sense to me. So if he could explain that one, I would really appreciate it. Problem is, it will never happen.
Yeah, but he doesn't know anything about engineering or design. But people assume he does.
Because he's an entertainer.
Entertainer, you hit the nail on the head.
He's a performer. As we saw in that clip, he's forever waving his arms about, getting up and trying to get people triggered by things he says, and then doesn't agree with their replies. I mean, that guy who walked off in the middle of his rampage.
Yeah.
That was quite indicative of the way he is viewed by other people, other scientists. And it was also noticeable that Bill Nye, the science guy, the only thing he did was to try to restrain Neil deGrasse Tyson. He didn't contribute much to it. So I'm not quite sure what it was he was trying to do in that presentation. And he had Richard Dawkins there, who would be interesting to get his views on it, but that wasn't asked. It was just Neil deGrasse Tyson performing as Neil deGrasse Tyson, the science person.
Yes, I'm sure they were on stage for a couple of hours with that many people, and they all got to speak on whatever they were speaking at the university, right? Yeah. This is just a short 8-minute clip of Neil, becoming quite animated. It's understandable. You don't expect people to be an authority on every aspect of a scientific topic or whatever. Neil, as a theoretical physicist, uses his brilliant mind, and it is a brilliant mind. He has a great imagination where you could contribute with that kind of thought, but he doesn't contribute.
No, he doesn't.
He doesn't go, oh, gee, it just came to me and pick up the phone and call Elon Musk and said, I know how to get those rockets to space, because he literally doesn't know anything about the physical aspects of building a rocket. But people assume that he does.
Well, people assume that he has knowledge of it and he knows what is required.
He's just parroting everybody else.
Yeah, and he has a platform to do it.
Yeah, and because he performs so well, he entertains so well, he's listened to. It doesn't mean to say he's right. It just means that he's entertaining. But he's actually deflecting people away from the activity that needs to be investigated.
And when he opened up, did you notice the one fella sitting beside him? He said, Neil, stay on topic. Something to that effect.
Yeah, and the other line, the guy's saying, these are facts. You can't argue the facts. And he says, watch me.
Oh, dear.
And that's what he said right there. Just watch me. Then he goes off on his animation and doesn't discuss it, right? No. If we were to sit down with him and pull some of the photographs up, by the way, that's what we're going to do.
What we're going to do now is we're going to go through these photo plates that Scott had made up a few years back, because a few subscribers were requesting to do a little bit more of this stuff. And this is something that we haven't actually done before, was just sit down and go one through the other until we get to the end, just to show everybody how much nonsense that NASA's putting out.
This is Apollo 17, of course. They made the excuse that they removed both back fenders and brought them back to Earth with them, which was interesting in that particular thing. That's one with the missing map on it. But there's actually two final resting sites for the lunar rover in Apollo 17. One that the wheels are perfectly straight, and the other one, the wheels are turned like that. So that's one of the two rovers from Apollo 17. of which they only took one with them. But in practice, they always had two. There's a particular photograph. The one on the left is, of course, Apollo 16, where the fender went missing. And then, of course, these guys were busy. So between simulations, about 5 months apart, they just left this equipment laying on the ground, and they come back and had to put a map on it for a fender so they wouldn't get all covered in dust. So that's between Apollo 16 and 17 in the simulation. Of course, none of this ever happened on the lunar surface because we can see that in the photographs. There's 16 where the rover broke down. That's the actual one of the suspension and steering arms there, actually broken off laying on the ground.
In that picture you've got of the rover parked on Apollo 17, it's image number 3, the fenders on that rover are both missing. But surely if they had repaired it, it would still be on the rover. So why is it missing?
Once that was pointed out that they're both missing, they claimed that they brought them back to Earth. Interesting enough, eh? And they do have the map and that fender on display in one of the museums that was on the lunar surface, claimed. But there are 2 final resting sites of the rover, one with the wheels straight and one without. Of course, this is showing that Apollo 15, 16, and 17 were all using the same rover because of the oil leak on the rear left tire. That's what I'm showing in these. All 3 had the same leaky thing, and considering the fact that they're hand built, that's almost impossible to have.
Yes, 3 errors.
3 separate machines on 3 separate missions, and they all had exactly the same problem. No, it's the same rover. This is an individual rover from Apollo 16, and it is identified because it has a double rib on the front left fender, and it's the only shot of that rover. And that's a nice, brand new, beautiful looking rover for the photo shoot, and it's got a double rib on that particular fender. No other rover in any shot has a double rib.
Oh, this is one of my favorites, showing the rails.
One's bent and the other one's welded together, and you can see the 2 same corner, and the suspension components are completely different behind it.
And then don't forget the tracks. Now, this is another interesting thing. Here you have hair-bone tracks, and in here, they're straight. And then you go back down here again, and they're hair-bone again. And it's not perspective.
No, it isn't. I mean, those tracks left on the surface are indications of what was actually happening on wherever that surface happens to be. Probably Menlo Park.
Because these are straight. You know, those are perfectly straight. These are not. They're chevron.
That straight can actually happen when one tire is running over the other and getting rid of it. I think the biggest point is you have a chevron pattern, which are on 2 different degree angles, and one is a much tighter pattern. That one's wider, and the other one's a much tighter pattern, and the chevron has less of a degree angle to it. That's not possible. That has to be a completely different tire. And not only that, that tire is physically wider at the same time. But the frame rails, you can't change the frame rails on the rover. There's that piece underneath as part of the steering and suspension that you see on the rover, and it's completely snapped off. Of course, this is at the end of it. And just by accident, Apollo 17, of course, has a golf ball right beside it.
Oh, that's good. That's convenient, isn't it?
Apollo 14 had the golf balls, but they seem to be doing an awful lot of golf out there.
Mm-hmm. Yeah.
Oh, yes, always the cue cards. I've always wondered how you could describe footprints and a disturbed area where rocks were moved, write it down, and document it before you even got there.
Or even describing the rock split open here and describing what's in it before you even arrived.
That's imagination for you.
Oh, yeah.
That's what the inside of the rock would look like, we think. Surprising they discovered it was for real.
Yeah, describing the mineral contents when you crack the rock open, describing the mineral contents inside. That's a pretty amazing thing to do considering you've never been on that location ever. I mean, if I could do that, I could tell you the mineral contents of a rock in your back garden.
Yeah, of course you could.
NASA could do it better because they've been doing it for 50 years like this.
Well, they remote viewed this. This is what happened. They remote viewed this.
Oh, yes. Yes, I forgot that they had those guys.
Yeah, they must have had Ingo Swann under contract.
This is one that was disputed that NASA actually changed their website about Jones Crater. First, they made it into a giant crater that the path of the rover actually then drove through, which the rover never drove through any of the craters. It would never get out again. Then they just said that Jones was a cluster. Well, Jones is also listed right there.
Yeah, he's the inspector.
He's the inspector. That little spot is the spot he was standing in. Interesting that it's right there. But NASA, I don't know if it was Phil Plait or one of the other guys there they actually took, when we posted this the first time, they actually took my snapshot of this and put it on their website.
Really?
Yes, and it's still there. It's on the journal site. Oh yes, now we have Buzz Aldrin's watch. And of course, this was recorded 59 minutes after he first sets foot on the lunar surface, and they should be on universal time. And it just seems that his watch should be set. I mean, it's very critical that his watch would be accurately set for timeline on it. And it's like 14 minutes after 11, and it should be somewhere after, 20 after 3 or something like that.
It's these little things which, on a major film studio, you would have continuity girls looking for the problems, which this is, where you've got the wrong time on it, where you've got things which are not supposed to be there. But they didn't appear to have anybody to do that on Apollo. Perhaps they ran out of budget.
Well, that would put him right on target if he was on Central Time. This photo was taken an hour after he so-called set foot on the lunar surface. That puts him right on time with the national 11 o'clock news Eastern Standard Daylight Savings Time. And that puts him at a quarter after 11, an hour later on Central Time. So now he's at Flagstaff. That's where that watch puts him. Oh yeah, this is beautiful because there's the photograph on the left of Neil Armstrong taking a picture of Buzz coming down the ladder. Except the live TV camera has Neil Armstrong not in the correct location to take that photograph, which means they've shot this sequence 2, 3, or 4 different times.
Look, I mean, Armstrong is right at the edge of this ladder. I mean, he's pretty much in line with the rail. Now, you come over here, he's not anywhere in line with this rail. Not even close.
Okay, well, we know where the camera's located when they open up the mesa, right? It's sitting down there, shooting straight up. The photograph that Neil is so-called taking, you can see both legs clearly. But from where he's standing, he can't see both legs clearly from the television recording. Neil's not in the position. He has to be in the position where he can see straight down past both those legs, and he cannot do that from where he's sitting in that photograph. And between that photograph and that particular shot there's within 1 second of where he needs to be standing, and he has to be over about a good 6 or 8 feet over to take that photograph. And of course, to take the photograph, he'd have to stand there for a few seconds to line it up to take it. So he would have to be within that shot of the TV camera, lining up to take that photograph. Oh, the double shadow.
Oh, yeah. That's beautiful, isn't it?
Self-explanatory.
And of course, that one of Buzz coming down the ladder with his foot not on the rung.
That's just incredible, too. If you go up and down the ladder long enough, you'll be able to do that.
But it's beautifully timed that they managed to get that picture of Buzz in midair coming down the ladder, because he's obviously moving. It's beautifully framed. It's so good you don't even need a caption. Spaceman coming out of capsule. That's basically what a good photograph does. It doesn't need a caption because you know what you're looking at when you see the picture, which is why it's one of the most used, that one and the one following it, one of the most used pictures to illustrate man on the moon. Because it looks so strange with the black sky behind and the lunar surface not overexposed in the photograph.
Oh, that is strange, isn't it?
It is.
And yet over here, look at this. Fall off. All this fall off over here from the TV camera's point of view. And then look at this. I don't understand why it is when this is supposed to be in shadow, people, and yet it's circularly lit up.
Well, that's where Neil is back there. What people don't understand, that little arrow pointing down there, that is Neil's backpack. His PLSS is
Right.
shining bright in the sunlight there.
Right. But you can't tell me that this backpack is going to light up all this that's in shade down here.
No, of course it's not.
And this is all in shade as well. Why is it lit up? This is supposed to be in the shade.
Yeah.
And same with this. This is in the shade, people.
And the shadow of the lander extends about 50, 60 feet beyond it. So the surface behind the lander is black. There's no light in there.
Yeah, and without any diffusion of light, without an atmosphere, it'll be dead black.
Exactly. Yeah, it would. Because you can see the top of his backpack in that picture of Aldrin coming down the ladder. The top of the backpack still has an amount of light on it. It's not jet black, it's grey, indicating there's a certain amount of light getting onto it. Right, so that the backpack itself is quite light coloured. It's white. But would it reflect that amount of light? I don't think so. I think it would be much harder, as you say, that there is no atmospheric diffusion on the moon, we're told, assuming this is the moon, which I doubt.
Look at how dark his legs are here, though.
Yeah, you can barely see them there.
And then look at this. This is the same picture. This is only a couple of frames afterwards.
The two images are within a second of each other of him coming down the ladder. He only has to lower that leg down to the next step, and then he's matched up exactly with the TV camera at that point.
Crazy stuff.
This is interesting because, of course, the explosion, when they separated between the lower and upper stage there, when it went off, the entire side of the craft blew out. And you can see that somebody's packed some extra stuff up in the side of there, because that's where it blew out of. I think they put those explosive bolts in there as well, just to try and destroy this machine. You're not sitting there. And then if you look at the on the top right-hand side there, if you've been practicing with a mock-up piece of machinery and you just leave it outside for a couple of years while you're practicing, and the paint starts peeling off, and you just happen to be some alpha male astronauts out there that have been practicing with this garbage, and you don't want it to be there, you need NASA to build you some new equipment that looks like it's real, not like a, shanty shack. I wouldn't be a bit surprised if they just blew the thing up to just try and destroy it. But then they take that same machine that we're on the ground at and do an orbital photograph with it. So they're not using miniatures, they're using a full-size replica.
Oh, absolutely.
Yeah.
And it's the same machine that got blown apart, and you can see the actual video when that blows up. Those panels are out there like that, and then they continue on to the orbital images of that. So they're using full-size pieces of equipment at that point.
Yeah, this is already bulging here.
Yeah, well, that's the side angle of it where they packed the explosives in to blow the side panels off of it. And if that was a real explosion with that real thin hull, they'd all be dead.
Oh, it'd be torn open like a sardine can.
Oh, yes, the rock with all the gloves in it. You can actually see that nice one in the middle there. You can see the white glove. You can see the rubber tip and the black ring on it. That's the rubber tip and the black ring. Just give it right away. But you can see the whole pattern there where they stuck it on the thing. But you imagine the contracts they had for different manufacturers to make gloves for them, because they would have at least 3 different manufacturers in competition, right? They needed to spread that money around. And they literally would get skid loads of them. And what do you do with them? Well, you take them out and you just bury them.
These are crazy, and these tips sticking out of here. But that's a whole glove right there.
Yeah, well, there's 4 fingers every time you look, isn't there?
Yeah. Well, the thumb's over here, and then there's the index, and then there's your other 3 there, and your pinky over here.
Yeah, that's the one picture I put up on my desktop because I couldn't figure out why that rake was positioned the way it was positioned. And I was just walking by and looked at the screen, and I realized I shouldn't be looking at the rake. I should be looking at the shadow. And the shadow made an arrow, and the arrow is pointing to the gloves. If that isn't intentional, I mean, the biggest part of the head with the program is I spent most of my time looking at why that wheel's off the ground. But that was not the point of that photograph. And these astronauts weren't just leaving clues, they were just pointing it out. And when you realize that each series of the astronauts between the different missions had a different method of pointing out the fraud. Oh yeah, these rocks move around a lot. They go from way out one side across to the other, so they're on one side of the rock, then they get to the other side of the rock, and then you can see that they sit there, and it's there, and then the next shot it disappears again.
Now they're in some other position. Now it's back again in the same position that this one's in, and now it's gone again.
From one side of the rock, a fair distance away from it, to the other side of the rock, and then disappears.
Yeah, gone.
Have to redress the set every time you're out there with that equipment.
And of course, NASA didn't expect anybody 50 years after the event to be examining their photographs for the details that they got wrong.
Well, people don't understand what it takes to examine these photographs and the length of time it takes. I probably spent an entire year looking at photographs without a real method in mind and found absolutely nothing.
But this is the same rock. I mean, you see, there's the little pyramid there inside the rock, and there it is there. And there's the top with a little ball on the top of it there. Oh, by the way, isn't it something that these rocks all come with little balls at the top? You see a lot of that in all of these photographs when you look at the rocks. All these little balls sitting up on the top of them.
But to give you an idea of just how much time it takes to get your memory down on the photographs, if you take a look at the top left photograph, you see the photo number, 2115, 21589, and then you look at the other two photographs on the other side, 2293 and 2294. You just can't glance at that. I knew exactly where to go back to find that image of the same rock.
These are quite a few photos later over here.
Yeah.
Oh my gosh, yeah, that's a lot of photos later.
That's a lot of photos you're going through, and then suddenly remember I saw that rock.
These guys have taken this rock here, moved it or relocated it over here, and then over here they picked it up again, and it's gone.
Yeah.
Except the photograph on the left is from a completely different magazine, magazine 141, compared to the others, which is 145.
Oh my God.
How many hundreds of photographs is that I was going through, and then able to go back and find it to compare it, that sequence of photographs in there. When you're sitting down, that could be 5-6 months apart, looking at those photographs, and I went back and found that and put that sequence together.
And you've got rocks missing.
You know what I find interesting, though? Look at the distance between these two rocks here that are beside this massive rock. Now over here, though, where's that massive rock? And yet these two are just about the same distance apart, except for this one's missing. This little rock's missing. So these have definitely been picked up and relocated to here.
Right. And people argued the fact that the person taking the photographs is in a different location. People are saying that it's behind the other rock because the photographer moved. But you can see how far he moved. He moved one step to the left. So he's just a little closer to the rover than the other shot. And you can see the footprints on the ground. He's standing in front and he's only moved over just that little bit. That wouldn't expose that back there. That much difference in angles he's taking the shot at would not change the fact that those rocks would disappear. Absolutely not. Anyway, of course, now we're back to Apollo 15 and the rover being damaged as the machine was dropped to the ground. Literally dropped to the ground. Gantry crane dropped this machine to the ground and hit hard enough to break the rover right off of its mounts. And there are the mounts and those little fine cables. That's the heaviest piece of equipment they got, and that is the size of the cables they needed to secure it right there. And people need to note that, because when we get to the hammer and the feather, there's a large gantry crane strap.
Dear, oh dear.
And that's the difference between Apollo 15 and Apollo 17. The wrinkle is still in both. Even in Apollo 17, it's the same exhaust bell housing on both machines, with the scratches are still there and the wrinkle's still there.
Yeah, that photograph of the film of the hammer and feather being dropped and arriving on the ground at the same time, that's been recreated by David Percy in his film, What Happened on the Moon. It's quite easy to do it. So you can show on Earth a hammer and a feather arriving on the ground at the same time.
There's the hammer and the feather on the left-hand shot of it.
Yeah.
And they didn't drop the hammer and the feather in anything other than to show off that large strap that's there. And we just showed you the amount of that they needed to hold the rover up. That's the heaviest piece of equipment they got. So what is that strap holding up? That's the one that broke, that dropped the entire limb in the simulation. And they just left it laying on the ground, and they used the hammer and feather drop and then photograph it. So you're looking at the hammer and feather, but what they're really showing you is the broken strap. Oh yes, we have some automobiles on set. Shotcrete them over and just keep shooting.
I really like, especially when you have the flare here around.
Oh, the back fender, everything, it's all there. Side glass windows kind of really give it away, doesn't it? Because they're just perfectly smooth. Pick the light up quite nicely.
This has to be one of my favorites, this 1947 Ford, especially when you see the headlight housing right here. I mean, you just don't have this happening by nature, especially when you have a window in there, right? There's your window.
Well, you can see the door frame.
There's the door frame right there.
A little flare in the back, at the back over the back tire. It's all there. You can see the wheel well, the whole 9 yards is there. And people argue. And of course, a 1960 Corvette, the guys that molded that rear together to get that design on there, to accidentally have the tow bar that's going on there, you can see the glass is pushed flat down. I mean, this car has been crushed and everything else. The front half of the car is missing. Like, you only have the car just from in front of the windshield. The engine's not there and the front end of the car is not there. But a piece of the suspension is still there.
By the way, look at this. There's the rotor. The hub is still there. Look at this.
Yeah.
Wow. CV axle or something like that here. Still there.
Well, it'll be the upper control arm.
Yeah.
The rear axle is sitting there, no tire on it. I mean, you can see where they just threw the shotcrete over it and it's kind of dripped down over top of the rear fender well, right? Back there. That curve is there. I don't care how you do it. You can have as many anomalies in a rock as you want. You can't put it together quite like that. And physically, for the size of the crater that it's in, it's the correct size for a vehicle. You can measure that crater out anytime you want.
That's a funny. I've never noticed this hub here, though, before. Now you can really see it, though. I mean, that's the whole control arm with the hub.
Yep.
Oh, by the way, there's the bearing cap right there, too.
Well, that's the front disc brake, yeah.
Yes, yeah.
Oh, yes. Here we have Rust on the Moon. Piece of equipment, central station, absolutely zero inside of it. No equipment. They claim all the computer stuff is underneath the bottom, laying on the ground there where they got all the cables put in, except the amount of equipment that they would need would fill half a house. And then we've got mold.
Mold. There's plenty of mold there. Look at it.
Everywhere.
Well, you know, their clean rooms at NASA weren't quite as good as hospital grade, I guess. You know what I mean? Like, people need to realize that all of this equipment we're looking at here was so-called prepared in clean rooms, packed up, put on a rocket, sent to the moon. And when they unpack it, this is what it looks like.
Look at the water ripples in between here.
The oil's actually cracked back. Sitting in the sun so long it just cracked open. The one on the left has mud that has taken the time to dry and got mold around it. Of course, you can't have mold on the moon, but we just saw a couple of shots of mold on the moon, right? And then, of course, the classic wet flag. The morning mist. And, of course, we saw when they landed that the dust so-called disappeared right away, didn't it? So it couldn't be from that.
Yeah, but you get that sort of thing in Arizona, don't you?
Yeah, it's only about 1 degree there right now.
Why would you need a rain guard? This is in space, people. This is where they claim this is, in space, this capsule. Why would you have water running in between the windows? Oh, well, that's moisture, though. I don't know how it gets in between the glass.
Yeah, but it's on the outside, it's on the inside, and it's been there long enough that the paint's peeling up. And the nice thing about these is we've got all of the photo numbers to go with them.
That's important to have that.
Most of them have that, so if people want to download this PowerPoint, they can refer to it to see that I have not altered any of these photographs. They are as they are. I don't do any kind of photo enhancements. These are the ones that are displayed by NASA.
Strange that nobody's edited these before they posted them. Or perhaps the people posted the pictures were not aware of the problems that they were putting up.
You know, I could understand if this was inside of a hangar and it was in controlled conditions and the door was open and they had a difference in temperatures. It would make sense. But what doesn't make sense is you have a half of a rain guard. That's what it looks like. But then, to make matters worse, what's all this aluminum duct tape doing here? It looks like it's holding it in. It looks like it's holding a part of the edge in or something. I don't know why you'd have that there.
We know that duct tape doesn't work in space because it would outgas. The adhesive would outgas.
It's peeling right up off of the window frame here. My God. My God. My God. My God.